Hey guys, I'm just going to do a basic concept overview of converging and diverging lenses. First off, a converging lens are convex shaped and they focus parallel lights to a common point. A diverging lens are concave shaped and they disperse parallel light rays from a common point. Some of the components of a lens system are the incoming light rays, the object, the lens, and the image produced. From the lens system, we can have values of DO, which is the distance of the object from the lens, DI, which is the distance of the image from the lens, and F, which is the focal length of the lens. Then, with the image produced, it could either be real or virtual. And a real image is where the image is on the opposite side of the incoming light rays, like this one. A virtual image is where the image is on the same side as the light rays. Then we can solve for the focal length, the distance of the object, and the distance of the image mathematically by using the thin lens equations, which is 1 over F equals 1 over DO plus 1 over DI. We use the thin lens equations assuming that the lenses are very thin and the light that passes through the lens is so small, so it's irrelevant, so we can ignore it. We can also find the image of an object by drawing a diagram, and here are some steps to find an image of an object using a converging lens. So first off, we want to draw a parallel ray to the lens, then refract it through the focal point. Then, and this is called the P ray as well. Then, we want to draw a ray through the center of the lens, like so, and this is called the M ray, and wherever the M ray and the P ray intersect, that is where the image is. Now for diverging lens, we do the same thing with the P ray. We draw it parallel to the axis, but the ray diverges out using the focal point as a guidance. Then we draw the M ray through the middle of the lens, and wherever it intersects, the P ray and the M ray intersects, that's where the image is. And there are multiple cases for the converging lens, but only one case for the diverging lens. So there are 3 resulting cases from the converging lens. So we have when the distance of the object is greater than twice the focal length, the image is real and it's inverted and it's smaller. When it's between twice the focal length and the focal length, the image is real, inverted, and bigger. And when it's smaller than the focal length, the image is virtual, upright, and bigger. And like I said, there was only one case for the diverging lens, and that's when the image is only virtual, upright, and small. And that's about it, guys. Thank you